Having understood the theory and calculations related to simply supported beams for finding axial force, shear force, and bending moment at various locations along the beam length, we now proceed with some practice problems in this lecture. In this practice problem, shear force and bending moment diagrams with the beam length and the corresponding values along the length are given. It is required to draw the schematic beam diagram with the supports and loading. You may please pause the video at this instant and resume after solving for the answer key to this problem. Welcome back. The answer key to the practice problem 4 is shown in this slide. We begin by observing the variation in the shear force ordinate values and the locus type. The value changes from plus 200 kilonewtons at the left to minus 200 kilonewtons at the right end, and that the variation is linear as seen from the shear force diagram. From the theory that the derivative of shear force with respect to x equals the rate of loading at a section, it is concluded that the loading is supposed to be a constant value throughout the length, hence denoting a uniformly distributed load to be acting. To estimate its value, we consider 2 points A and C and the corresponding shear force values and calculate the variation in shear force values for the length between them. That is 200 minus 0 kilonewtons over a length of 2 meters, which comes to 100 kilonewtons per meter length. Now, since there is no abrupt change in the values of the shear force over the length except at its ends, it can be concluded that the supports should be acting at the ends and not in the intermediate portion. We hence place a pinned support at the left end and a roller support at the right end and name them accordingly. Finally, we observe that the bending moment values at A and B are not zero, but have a value of minus 133 kilonewton meter, meaning that there is a concentrated hogging moment applied at each of the ends of the same value. The direction of the concentrated moment applied at A is hence shown in a counterclockwise direction, while the moment applied at B is shown in a clockwise direction, both of which tend to bend the beam to create a hogging moment near the ends. To visualize this situation, a tentative dashed curve is shown on the schematic beam diagram, indicating the possible deflection curve. It is also seen from the bending moment diagram that the bending moment values are positive, indicating a sagging moment near the major part of the center portion. Hence, the beam tends to bend as shown by dashed lines. At the points of contraflexure or inflection, the bent beam shows no sign of bending upwards or downwards, indicating a zero bending moment at the sections. In the next practice problem, we have all the types of loads shown acting on the simply supported beam. You may again pause the video at this instant, solve the problem and resume the video for the answer key to this problem. Welcome back again. Here the reference end is taken as the end B only for the sake of convenience of calculations. It is simpler to represent the part of the uniformly varying load at region AC created by a section by only one term, that is by a single equivalent point load if the reference is taken as the end B from where the variable x is measured. Contrary to this, if the end A were taken as a reference from where x is measured, then this would necessitate writing two terms for the part of the uniformly varying load created by the section, that is an equivalent point load for the uniformly distributed load and another equivalent point load for the uniformly varying load on top of the uniformly distributed load. It is important to note that the final values of the axial force, shear force and bending moment would remain unchanged irrespective of the selection of the reference end, be it end A or end B. The final practice problem for this lecture consists of a frame AECDB as shown in the slide with the dimensions and the loadings given. It is required to consider separate portions of this frame as free body diagrams and consider each one as a separate entity for the analysis of resistive forces and moments along their respective lengths. You may again consider pausing the video at this instant and resume after the solution is ready for the answer key. Welcome back again. Here, we first consider the entire frame in static equilibrium, apply the three laws and find the reactive forces at the supports. Then we take sections at points C and D to create three separate entities, namely part AC, part CD and part DB. We consider each one of them as a free body diagram and show the forces and moments acting at the key points so that each part also is in static equilibrium. Once the forces and moments acting on these parts are known, we may proceed analyzing each of these parts individually for axial force, shear force, and bending moment along their respective lengths and plot them accordingly in the form of diagrams. In the next lecture, we start with a new section on special beam applications. We shall discuss in particular the analysis of internal hinge or bending moment release and a short introduction on axial force release and shear force release.